Welcome back, advanced algebra students. Today we're going to be solving absolute value equations. Absolute value of a number is the number of units or distance it is from 0 on the number line. Remember, distance is never negative. I like to think of traveling to a town. Say you go to Fairmont, it's about 20 miles away. When you come back to Blue Earth, it is not negative 20 miles, it is 20 more miles, because distance traveled is never negative. We use the symbol, these straight lines around x, so the absolute value, to represent the absolute value of the number x. So some examples down here at the bottom: the absolute value of 4 is equal to 4, the absolute value of negative 6 is 6, and the absolute value of negative 9.8 is 9.8. Here we're asked to evaluate some absolute value expressions given some values for variables. X equals negative 2, y equals 4, and z equals 1.6. So all we have to do is input those values into these absolute value expressions. So the first one, we would replace y with 4 and evaluate the absolute value of negative 2 times 4 minus 5. Well, negative 2 times 4 is negative 8 minus 5. That's going to be equal to the absolute value of negative 13, which is equal to 13. Part B, we're going to input negative 2 for x, and we would get negative absolute value of 4 times negative 2 plus 9. 4 times negative 2 again is negative 8 plus 9, and we have that negative sign on the outside, is equal to the opposite of the absolute value of 1. Well, the absolute value of 1 is 1, so the opposite of 1 is going to be negative 1, and that's going to be our answer. Part C, we're going to input 1.6 in for z. So we have 7 minus the absolute value of 3 times 1.6 plus 10. So we evaluate everything inside the absolute value sign. That's because an absolute value sign is a grouping symbol. So 3 times 1.6 is 4.8 plus 10. 4.8 plus 10 is 14.8. That's going to be equal to 7 minus the absolute value of 14.8 is 14.8. I'm running out of room here, so I'm going to write it above. 7 minus 14.8 is going to be negative 7.8. When you're solving absolute value equations, you're going to actually solve two problems. You're going to split it up, and you're going to set, in this case in part A, you're going to set x minus 9 equal to a positive 17, and x minus 9 equal to a negative 17. Because the value of x minus 9 can be positive 17 or negative 17, because you're going to take the absolute value of that, and that would equal 17. So we're checking for two possible answers. Notice that the x minus 9 stays the same on both sides. All we're doing is setting it equal to a positive and negative of the right side. And then we solve. So we add 9, add 9. You're going to solve it the same way on both sides. You get x is equal to 26, and x is equal to negative 17 plus 9 is going to be negative 8. Those would be the two possible solutions for x. In part B, very similar. The only difference for this problem is you're going to divide both sides by 5 because you want to get the absolute value portion of this problem by itself. So I'm going to divide by 5 right away, and I get x plus 4 is equal to 17 divided by 5 would be 3.4, I believe. You can check me on that. That's going to be one side, and then you're going to have x plus 4 is equal to negative 3.4. Then I'm going to add, sorry, not add this time, it's going to be subtraction. Subtract 4 from both sides of the equation, and we get x is equal to 3.4 minus 4 is a negative 0.6, and on the right side x is going to be equal to negative 7.4. So those would be the two solutions. Part A on this slide has a number that is subtracted outside of the absolute value sign, but again, you want to get the absolute value portion of this problem by itself. So I'm going to go right away and add 4 to both sides. Now I have the problem, the absolute value of x plus 3 is equal to 21. And I split that up into two problems. X plus 3 is equal to a positive 21, and then x plus 3 is equal to a negative 21. And then I subtract 3, and I get x is equal to 18, and x is equal to negative 24. Those are the two possible solutions. On the right side, part B, I'm going to again get the absolute value portion of this problem by itself. I'm going to do that by dividing by 3, and I would get the absolute value of x plus 6 is equal to 9x divided by 3 is 3x, and negative 6 divided by 3 is a negative 2. And then I proceed with this problem. X plus 6 equals 3x minus 2, just as it was written above. Now the other side is a little bit tricky because you have to take the opposite of 3x minus 2. So you change the signs in front of the 3 and the 2. So it's going to be x plus 6 is equal to negative 3x plus 2. And I'm just going to go ahead and solve as I normally would. I'm going to subtract 6 from both sides. At the same time, I'm going to add 3x. That would eliminate that 3x. Add 3x to the left side. So now I have 4x is equal to negative 4. Divide by 4. Divide by 4. X is equal to negative 1. And if I do it on the right, or sorry, the left side, I'm going to do it a little bit differently. I'm going to add 2, and subtract x. That's going to eliminate x from the left side, and it's going to eliminate the negative 2 from the right side. And I end up getting 8 is equal to 2x divided by 2. X is equal to 4. Now what you need to do is, when you have an x value on both sides, is you need to check your answer and make sure it works. So we have two possible answers, 4 and negative 1. If you input 4, on the left side, 4 plus 6 is equal to 10, and the absolute value of 10 is 10. And so you would get 30. On the right side, if you let x equal 4. 9 times 4 is 36, minus 6 is equal to 30. So that works. That checked out. But we're going to check negative 1. On the left side, if I input negative 1, negative 1 plus 6 is 5. The absolute value of 5 is 5 times 3 is 15. So we get 15 on the left side. On the right side, if I put in negative 1, 9 times negative 1 is negative 9. Minus 6 is negative 15. Well, that does not equal. So we have what we call an extraneous solution here. We did everything correctly. There's nothing that we did wrong in our work, but since this is an absolute value problem, not all the possible solutions that you come up with are actually going to work. So negative 1 is not an answer, only 4. Here's another situation you might run into when you're talking about absolute value equations. Remember that absolute value of a number equals a positive number. So here we have the absolute value of 2x plus 1 is equal to negative 13. Well, that is not possible because the absolute value of anything, no matter what you make x, is going to be positive. And on the right side here we have a negative 13. So there is no solution for this problem. You can say no solution, or you could go and put a 0 and a slash through it. That indicates no solution. I want you to take a moment and pause the video, look at this problem, try to complete it on your own, and I'm going to show you the solution here in a couple seconds. So if you did your work correctly and you set the absolute value portion of this problem equal to a minus 4 on one side and negative a plus 4, notice I changed the sign both in front of the a and the 4, you should have gotten an answer of a is equal to negative 11 and a is equal to negative 1. But again, you need to check your solutions. If you input negative 11 and negative 1 in for a, just looking at the right side of the original equation, okay, if you put in negative 11 and negative 1 and subtract 4, you're going to get a negative answer. But again, an absolute value is always positive, so this absolute value cannot equal a negative answer. So, in conclusion, this problem does not have a solution. And you can write the 0 with the slash through it. Okay, this concludes section 1-5. I want you to take a look at your calendar and notice that there is a quiz covering sections 1.1 to 1.5 coming up.